or?
I just had trouble
number
going
one,
back to sine
basically
squares.
all the trig ones I was having problems with.
Okay, so number one we'll do because of the trig. And what'd you say, Abby?
That was number one. It just had the sine squared in it, and going backwards from that always confuses me.
Yeah.
Yeah, let's see. This, I mean, it might have been a good one for NINT, but I always like to see if I can figure it out.
That was an option? I didn't do that like all assignment. Darn.
No, I think, and actually I didn't want it to be an option for this assignment. This coming assignment, it'll be an option because there's so many that are like borderline, you can't do them, or you just can't do them by hand and you have to use NINT. So, and it's more important to like know how to set it up. But this assignment, I did want people to kind of try to do it without it. So no, I'm glad that you guys did. So, but hopefully it's doable, but we'll see. Okay, so it's the integral from negative pi over 3 to pi over 3 because they gave you that. This is number one of 1/2 secant squared e minus a negative 4 sine squared t dt. And this will go plus. Well, I mean, the good news is I guess we do know how to go backwards from this one because that's just 1/2 tan, right?
Mm-hmm.
Yeah, derivative of tan is secant squared. Yeah. Okay. Sine squared. You know what I'm gonna do is I'm gonna split this into two different ones, like pi over 3 to pi over 3, 1/2 out front, and then secant squared. Right, and then plus 4 negative pi over 3 to pi over 3 of sine squared t. I mean, sine squared is 1 minus cosine squared. Not sure that actually helps us. At first I was thinking it was like sine 2t, and then we could split it up, but that does not help either.
I asked Joel for help on this one, and he had me using some like half angle formula or something, where sine squared was like 2 minus 2 cosine of 2t or something. Or no, it was 1/2. I don't remember what it was exactly.
Yeah, this is gross. Yep, it is. So this, I'm actually like cheating and looking up it online right now. Yeah, this person is using that method that you were just describing. Gross. So yeah, this person that's yes. On this one, I probably would just NINT, but this is what Joel was doing so that you can know Emma, and this is what you'd have to do is like sine squared t is equal to 1 minus cosine squared, right? But then like we actually know cosine 2x is equal to cosine squared x minus sine squared. And so then they basically, no, actually, hang on. Oh, this is gross. Sorry, friends. While I'm explaining this, if somebody wants to NINT it, feel free.
Yep, I'm NINTing it.
All right, Abby's gonna NINT it while we're doing it, but this is actually, another one of this is 1 minus sine squared x like this. So you could subtract 1 and divide by -2, and so get cosine 2x minus 1 over -2 equals sine squared. And so then you could end up putting this in there, which means you can pull out the -2. Wow, yeah, I did not know this one was that gross. And divide it there, but then this would be cosine 2x minus 1. And then you could go backwards from that, which is just so bad. So you'd have 1/2 tan t minus 2 times backwards from cosine 2x is just a half sine 2x, right? Because backwards from cosine is sine, and with a 2, it'd be that, and then minus x, because obviously a minus 1 will become that. And then you could distribute this -2. Yeah, I would, oh, this is, I don't know why I turned these twos. These are still pies over 3s. So that is really gross. So what I would honestly on this one, I will not give you one this hard, to do by hand. I would just hit the whole original thing. Abby, did you hit the whole original thing?
Yeah, but I might have typed it in wrong because I got an error.
Oh, well, that's bad. Are you in degree mode or radian mode?
Radian.
Okay, just making sure. Because then I would get this from -pi/3 to pi/3. Yeah, that was an adventure though, Emma. I'm glad that Joel still remembers that though. Like, what a champ. I guess I can go type it in.
He looked it up in his Calc 3 book.
I see. Yeah, that's really gross. I can go look it up in my, or once I can go into it once we plug this in. But then you plug in pi/3. What's tan of pi/3?
Apologies for the unintentional slander.
Tan of pi/3 is √3
I think so.
minus sine of 2 pi/3, which is √3/2. 2 pi/3 is over here. Minus 2 times pi/3. And that's just when you plug in positive pi/3. Then when you subtract out, but these actually go away, so that's nice. So you just get -2 pi/3. And then if you subtract out what you get when you plug in negative pi/3, be 1/2 times -√3 minus -2 pi/3 would be -√3/2. So these cancel out again. And then plus, why am I getting a negative? That's very bizarre. I get -2 pi/3, and that doesn't make any sense.
When I did it, I got √3, and I don't know what I did either, so I don't know.
This is very bizarre, because we should not have gotten a negative number, because we did do the right one on top and the right one on bottom. I'm pretty sure. Yeah. No sense to have it gone the other way. Here, well, I will plug it in. I will plug it into Nint and see what we get. That is so bizarre. I'm still mainly just used this to, oh, I know why. Friends, no wonder. Negative times this is a plus, and so then these would both be positive. So I think we should get +4 pi/3. That makes me feel better. Okay, let me plug it into Nint to see if we get 4 pi/3, and then we'll leave the first page behind. Whew. Sorry about that. That was way grosser than I thought. My bad. But the other ones that weren't trig went okay?
I was having problems with 15 too, but aside from that, I think so, yeah.
Nice. And yeah, we'll head to the second page after this. All right, here we go. Minting this and seeing if we get sorry, it takes me forever to plug things into Mint on the computer. I'm a little bit afraid. I let one of my Algebra 2 kids who can't afford to borrow my graphing calculator for the year, but now that we're not coming back to school, I'm like, am I ever going to see that again?
You know how we're doing our lockers?
Or like returning textbooks or anything?
Yeah, that's a good point. Yeah, I got nothing.
Or getting summer homework. Like, I don't know how any of this is gonna work.
Right.
Do we even have like a last day of school?
Like at this point, no. Like I think they're gonna have to wait for the state to like say that they're like letting everybody in again, and then they'll be able to like plan a locker clean out day and all of that stuff. which is nuts. Unless before then they decide to just let, like people with the last name of A in at this time, and then the next day they clean and let, I don't know.
Yeah.
Do they have any idea, like, have they been brainstorming ideas for graduation if we can't do a graduation, like, even if it's in the summer?
I think they're working on that, but they haven't said anything definitive yet either on that.
I really want a ceremony.
Yeah, that's my hope is that they wait and then like do something in like late June or something.
Yeah.
So, yeah, we'll have to see. Okay, great news, everyone, is despite all of that, we definitely got the right answer and it worked. And if you nint it, so Abby, I don't know what you did. If you nint it, you're supposed to get this, and that is the same as 4 pi over 3.
I probably plugged something in wrong.
Okay, yeah, so you have to just go back and double check. But yeah, Emma, good. I'm glad that you gave me that hint because I would have not remembered to do that. But yeah, I will not give you one of those without nint. Sorry about that. That's gross. Are we good on 2, 3, and 4?
Yeah.
Yeah, I think so.
Oh, wait, 4? I think, I got an answer that doesn't seem right.
So for double check, here's your setup. The setup should be from -2 to 0 with a cubic on top.
Mm-hmm.
Then you subtract out the parabola. And then you also have to do the integral from 0 to 2 with the parabola on top and subtract out the cubic. Does that look right so far?
Yep, that's what I did. What's the answer?
I hopefully have that in my notebook, but I am not sure, but I can look.
Because I got 16, but that seems like too much.
What'd you get, Sarah?
16?
Yeah, I got
That's
16.
what I got.
Okay, let's go with it.
I was just looking at
I
the
think-
picture, it just looked like it shouldn't be 16.
I think it's because the Y scale is really off
Yeah.
from the X
Oh.
scale.
Okay, it's 2 to 1.
Yeah. Nice.
Because yeah, I just looked at that picture and looked at my answer and I was like, wait a minute, there's no way that's 16.
Yeah. I went with it because it was a nice number.
Yeah, same.
That is what's nice about that one. All right, let's see. I'm heading down to the second page then, starting at the 1. Like,
Okay.
let's, before we hit 12 through 15, let's do anything from 5 to 11. What do you guys got on 5 to 11?
8.
8. Oh, yeah. This is one of those Y integration ones, I would think.
I think it got kind of ugly.
Yeah. So with these, I mean, I'll go ahead and show you on Desmos again what it looks like so we can see it. But I would say, like, some people are just like a lot of other years when I do this when we're in class, I have a lot of students ask, like, Wendell, can we just make it like this? And then just pretend everything is in X's or like we normally do, and then graph it from there. And my answer to that is yes, but the reason why integration helps you is for this section that we're going to go into today, because you can't necessarily switch things around for like what we're heading into. But if it would make things easier to like visualize things like this, feel free, because then you're actually going to visualize, oh, this is a downward facing normal parabola, and this one is up to, and then is a downward facing parabola that's steeper, and we're looking for this. But oh, I just erased what I was not intending to erase. But the good news is we can actually still do it. If you ever wanted to double check your equations in Desmos to make sure you're graphing them correctly, feel free. But if I see that Y's are squared, then I'm like, okay, this thing is a sideways facing parabola. And I've taught enough algebra 2 that I know that this is just a normal sideways facing parabola like this. But it's to the left because it's a negative. And then this one, if I didn't teach calculus regularly, I probably wouldn't recognize this one. So it's just great to go to Desmos and be like, okay, what does this look like again? So if you needed a quick refresher, you could hop over to Desmos and type in x equals -3y squared plus 2 and go, oh, that's what this looks like. And then here's what's really convenient is right at -1 and 1, these things are going to meet right there. Is that okay for everybody?
Mm-hmm.
Yeah. And just so you guys know, if you like, obviously, like on a test, like especially for you, Abby, like AP test wise, like you're not going to have a, you know, Desmos just at your disposal, right?
Yeah.
So if you're like, man, how do you do these? What you'd have to do is you'd actually have to like solve this original equation for y. So you'd have to like square root both sides. Oh, the negative's on the inside. So you have to subtract x to the other side and then square root. So you'd actually get y equals -√x. But that'd only be the top. Oh, root -x. Sorry.
Yeah, that's what I started doing. Like I started solving them, and then the second equation got kind of ugly.
Yeah, and so both of them are going to be really ugly, and you have to actually graph 4 equations to get this because it'd be like the bottom and then the top and then the bottom and then the top. So basically, that's why people might switch the x and y, is just so they don't have to like solve things for that. So if you need an easy way out of that one, switch your x and y, but that's kind of what this one looks like. Now that we're right here though, here's the main thing is I want to see if you guys can get practice with y integration. So if we're looking basically from like bottom to top here, right? So what are our bounds going to be and what equation are we subtracting from what?
It's from -1 to 1,
Nice.
right?
Good.
And then the steep one is on top.
Yeah, so then basically you always look at it like you're leaning your head to the right, right? So you lean your head to the right shoulder and then you're like, oh, the one with the 2 minus 3y squared, that's the steeper one's on top. And then you subtract off the -y squared dy. And then this one's not bad from there, but how are you guys on the y integration there? So this will be plus, and so it'll be 2 minus 2y squared. Yeah, it is so much nicer when they don't have trig involved, isn't it? And then you plug in 1 and -1. So when you plug in 1, you get 2 minus 2/3. When you plug in -1, you get -2 plus 2/3. But then you subtract and you get 2 minus 2/3 plus 2 minus 2/3. So 4 minus 1 and 1/3. So 2 and 2/3.
Nice.
That's what I got.
Sweet. Nice. Any other ones in between 5 and 11?
10 and 11.
Do like one of those trig ones.
Yeah, let's do 10 since Abby just said that. Is that cool?
Yeah.
Oh, what am I writing? Okay, so 10, y equals sine pi over 2x and y equals x. This is one of those that obviously I know what y equals x looks like. That's fine. This is one of those that would be nice to graph, you know, on Desmos or on your graphing calculator. Like I know that pi over 2 changes the period. Like I think it's like 2 pi divided by pi over 2, which would actually become 4. That means the period of sine in this case is like a whole number. It's not in terms of pi this time, like usually you're 2. So I think it's actually like essentially saying that sine would be like this, because it would go through at 2 and then it would go under and go up at 4. So I'm pretty sure it's just this guy. But you could always, again, graph in Desmos or on your calculator, double check that. So if I come back here to Desmos to double check this, y equals x, and then y equals sine Oh, I forgot that I can just type pi over 2x. Yeah, boom. And well, actually, does it give us bounds?
No.
So then if it doesn't
think-
give us bounds, then I think it wants both of these. But we can just find one and double it. Everybody okay with that?
Yeah.
So that would have been something that, unless I had double checked it, I would have kind of forgotten. I mean, it makes sense, but I would have forgotten that this one went like this, and then we had both. But we'll just find one. So we're actually going from 0 to 1. Believe it or not, let's double check that. It does most, but I'm pretty sure. Yeah, look at there, this is 0.11. So that's why they put the pi over 2 in there, so that it meets so nice. Oh, that's not what I want. So sorry. Here we go. So you're going to go from 0 to 1, and then sine of pi over 2, x is on top, and then x is on bottom. And we're going backwards. So the hardest part of this one is going backwards from here. What's backwards from sine of pi over 2x?
No.
I
Wait,
got
negative.
-2 over pi cosine pi over 2x, but I really doubt that that's correct.
I think that is right. And because, yeah,
Yeah.
Abby, you were negative. Because to go from cosine to sine, we need to make it negative. And it's pi over 2. And then you have to attach the reciprocal of the inside. Yeah. Yeah, I like it. And then this is 1/2 x squared. To go backwards from the x. And then we got to plug in 0 and 1. Praise God that they're easy numbers to plug in. So if we plug in 1, what's cosine of pi over 2?
0?
0, yeah.
Yeah, so this is 0 when I plug in 1, so that's all 0. And then when I plug in 1 to the 1/2 x, that's minus 1/2. So when you plug in 1 to both of these, you just get 0 minus 1/2. And then I'm going to plug in 0. But isn't cosine of 0 1?
Yeah.
Yeah.
Then I'm going to take 1 times -2 over pi, so it's like that. And then I plug in 0 to the x squared, and that's just 0. So that's easy. So then I've got -1/2 plus 2 over pi. And honestly, you could leave it like that. If you ninted this one, oh, we have to double it though. Which might actually be better. If we double this, we just take both parts times 2. So it's -1 plus 4 over pi. And you know what? Why not? So basically it's 4 minus pi over pi. I'm not going to bother double checking in int. I feel very confident in ourselves. If I'm looking at, did you guys have trouble with number 11 because it has tan squared in there?
Yeah.
So that one I won't finish, but I'll step up really quick. Honestly, you just have to figure out which one of these is on top, but considering one of them's negative, my guess is the positive one's on top. The only thing you have to be careful of is, everybody see how the x's are by themselves?
Mm-hmm.
That means we're using y integration. And I'm not sure they gave you the bounds in terms of y. Maybe they did. That's a difficult thing to take in. My guess is actually that they did, because it wouldn't make sense to go otherwise. But I'm actually curious what these look like. What does it look like for x to equal tan of y squared? Whoa. And then the other one would go the other way. Yeah, I think they gave you the bounds in terms of y. So that one would be confusing unless I told you that the bounds are in terms of y. So I apologize on that one. Oh, we just lost somebody. Bye, whoever we lost. negative pi over 4 to pi over 4 of this guy on top minus a negative tan squared y on the bottom. So we are just going to get 2 tan squared y, where I can pull the 2 out front. But if you're wondering how do you go backwards from tan squared, this is where I would definitely use my identity, which is 1 plus tan squared. Or no, 1 plus secant squared. I need to make sure I figure it out here. You divide that by cosine, you get tan squared plus 1 equals secant squared. Yeah, so secant squared minus 1. So basically, you have to replace this with secant squared minus 1, because that you can go backwards from. So really, all these trig ones, I'm not going to make you know an identity to go backwards. That really is more of like a Calc 2 thing. So then if you went backwards from this, backwards from secant is tan, backwards from 1 is a y, and then it's from pi over 4 to negative pi over 4. I won't finish that one, but that was gross. You'd have to finish it from there. Actually, you know, I said we're not going to finish it, but it just begs to be finished. 2 tan y minus 2y from pi over 4 to negative pi over 4. This is actually not as bad as you think, because what's tan of pi over 4?
1.
Yeah. So it's 2 minus 2 times pi over 4. But then you're going to have to subtract off tan of negative pi over 4 is negative 1, right? So you have negative 2, but then plus 2 times pi over 4. And then when you distribute this, the pi over 4s are going to go away and you're just going to get 4. That one, that's why that one just begs to be finished. I need to somebody in there waiting. Oh, Sarah Brandon got kicked off. She's coming back.
I'll let her in. Oh.
Hey, Sarah, welcome back.
Thanks.
No problem. All right. Let's go on. Those trig ones were tough though. Great work on those peeps. Let's go. I think I'm gonna say we'll skip 12 because 12 is a lot like 8, which we did. So it's got some y bounds. Of the last 3, maybe we'll do 2 of the 3. We won't do all of them if you guys need them. What do you guys want to hit from the last 3?
15.
15 for sure. Fun fact, I've never done this problem. I took the book's problem and I alternated it. So let's do it and see what happens. Part A, isolate y. How'd you guys do with that? Did you guys do okay on getting y by itself?
I did not start that one because all of those really confused me.
So the main thing is the word isolate means get by itself. So we'll get y by itself. So y squared over 16 equals 1 minus x squared over 25. I mean, you could get a common denominator if you want. You don't have to. It's kind of up to you. Why don't we? Why not? So I'll make this a 25 over 25. So that it can be y squared over 16 equals 25 minus x squared over 25. And then we'd take this all times 16. And then we're going to have to root it. Isn't 16 times 25 like 400?
That would make sense, but I honestly have no idea.
I'm pretty sure it is. So this would be, actually, hang on, no, let's not distribute that. Let's just square root this. Because if we square root this right here, we can square root the 4 and the 25. We can't square root the 25 minus x squared because that's kind of, it's got the subtraction, so it's stuck. But this would be 4 times 25 minus x squared over 5. And that's what y would equal. Oh, this still has a root on it though. And it would be plus or minus technically, because essentially the top one would give us the top part of the ellipse and the bottom one would give us the bottom part. Kind of like, do you guys remember whenever we were doing circles, like x squared plus y squared equals 9 would be like a circle of radius 3. But technically, if you got like y by itself, the equation y equals root 9 minus x squared, that would be like the top of the equation.
Mm-hmm.
And then y equals negative root 9 minus x squared would be the bottom, right? That's kind of what's going on with this ellipse. So it says isolate that. And then it says set up an integral with appropriate bounds to find the area of the ellipse. So part B is just setting up the integral and part C is doing it. So part B is, well, actually, here's the thing. We don't need both positive and negative because if we just do the top, we're going to find the area under that and then we can double it, right? I don't know about you guys, but I don't want to take the area of the top minus the area of the bottom. I would rather just take the area of one of them and double it. Is that okay for everybody?
Yeah.
Yeah.
Okay. Now the main thing is what are the bounds?
-5 to 5, I think.
Yeah, perfect. So basically you just needed to know from an ellipse that that this would be from -5 and then 5 and then 4 and then 4, right? You square root those bottom numbers on the original equation. So this is actually just the integral from, actually, if you guys want, should we just go from 0 to 5 and then quadruple it so we can plug in 0?
Yeah.
Sweet, let's do it. Because then we're just finding like this portion right now, but we can just quadruple it and we're good. I'm trying to think. This might actually have to be something that we nint because we could pull the 4/5 out, but without substitution, like, because I would want to use like a q and make q x squared, but dq would have like a -2x in it, and that's not anywhere else. Like, this might be something we have to nint, to be honest. So anybody want to, yeah, go ahead. What's somebody saying? This might also be like an inverse trig one, which is really gross, but we don't need to do it by that. So yeah, somebody just nint this, and then we'll take it times 4/5, and then we'll quadruple it, so we'll take it times 4.
15.7.
Nice.
That's including the 4/5, so you don't need to.
Oh, excellent. And then just take that times 4. So 62.8.
Yep.
Did I do that mental math right?
Yep.
Sweet. Yeah, I want to say that this is a trig inverse one that you'll cover in Calc 2. Like, you'll learn how to go backwards from that. I think I helped Will with one of those this year, but we don't need to do that by hand. Sweet. Yeah, do you guys want to do 13 or 14 before we're done? You guys do it.
Sure. 14 maybe?
Yeah.
Yeah, I think I remember having weird things happen with that. I don't know.
Perfect.
That one's just got like a lot of bounds on it, it looks like.
Yeah, so first quadrant, bounded on the left by the y-axis. That's helpful. Below by the line y equals x over 4. Did you guys recognize that this is literally just the same thing as y equals 1/4 x?
Yeah.
Nice, because then you can just go, oh, it's just a line like this. So it's below by that line, above by the curve. Above left. They're making some distinctions here. Well, that's nice of them. So above left by the curve, y equals 1 plus root x. 1 plus root x should start at 1 and then go up 1 over 1. It should be kind of like this. And actually by here, it should be here, I think. Because it's just a square root guy. But then it says above right by the curve. This one I have no idea what it looks like without plotting it. So the green one was y equals 1 plus root x. And then above right by the curve, y equals 2 over root x. Well, this thing, you can't plug in 0 because the square root of 0 is 0 and 2 divided by 0 is undefined. But you could plug in 1, and the square root of 1 is 1, and 2 divided by 1 is 2. So at 1, it's right here at 2. And at 4, it's actually right here at 1. But like at 2, who knows? It's like at 2 over root 2. So this thing does something like this. And it did say it's bound by the axis as well, the y-axis. So that's here. So essentially, we are looking for this. Ew. We could actually do this in several different ways. I think only one of them we can do without a calculator. So what do you guys think? What way do you try?
If you split it up into 2 different halves with different curves on top.
Yes, and that's perfect. And then here's my debate: is if we split it this way, everybody with me that I could split it right there.
Mm-hmm.
If I split it this way, I've got to find this point, and this is the thing.
It's 1, 2, so it's actually nice.
Oh, really?
Yeah.
Oh, I know what I did. I thought it's supposed to be a 1, 2. Never mind. I drew my red curve wrong. Because I said.
I have it on Desmos here.
Yeah, when I plugged in 1, I did get 2, but I thought that this was 1, 2, but that's not 1. 1, 2's right here. Aha. Never
I don't know
mind.
if anyone can see that, but that's a graph.
That's perfect. Yeah. Okay, this is much better. Then let's do it. I like that. We can totally do this without a calculator now. I forgot that was where that was. Yes, pays to double check this. I was thinking you could do it by y integration because you could go sideways and then split it up like this. But we're going to get the same answer either way. So why not keep it in terms of, I was thinking we had to do that if it was going to be gross, but if we can keep it in terms of x, let's do it. So here we go. If we find this guy first, what are our bounds and what's on top and bottom?
0 to 1.
Nice.
1 plus root x is on top, and then the bottom is x over 4.
Nice. And then the second region is the integral from 1 to 4.
Yeah.
Nice. And then 2 over root x minus x over 4. All right, this is a great way to finish out homework, friends. I'm feeling great. So the one thing I'm going to do is I'm going to go ahead and rewrite like root x is x to the 1/2. Is that okay for everybody?
Mm-hmm.
So now I've got x plus x to the 3 over 2, but attach a 2/3 minus, what is this one, 8 squared? Bless you.
1/8 x squared. Yeah, that's what I
Yeah. And then plugging in 0 is awesome, again, when we can do that. So we don't have to worry about that. But plugging in 1 is 1 plus 2/3 minus an 1/8. So we can clean that up, I guess. But
I think things cancel once you start adding the other integral.
the other one, sweet. I'll just do this then. I'll leave it at 5/3 minus an 1/8. All right. So now I come in here. I'm going to make this one 2x to the -1/2 before I go up. So now I'm going to go backwards. So this is x to the 1/2, but you have to attach, it would be 4x to the 1/2, I think. Yeah. And then minus 1/8 x squared again from 1 to 4. All right, and we plug in 4. That's actually really nice. Square root of 4 is, because this is a square root, right? So square root of 4 is 2. 4 times 2 is 8. And then square root of 16 times an 1/8 is 2. So 8 minus 2 is that one. That's nice. Subtract out what we get when we plug in 1. Square root of 1 is 1 times 4 is 4. Minus an 1/8. So then I'll distribute this. I'm going to have 6 minus 4 plus an eighth. And so that's 2 plus an eighth. But then I'm going to add it to this, because that was my other one. And the eighths go away. I like that. That's beautiful. So it's just 2 plus 5/3. And 5/3 was 1 2/3. So it's 3 2/3. Bam. Usta. Yeah, I will say that my friends, I'm pretty sure I say this in both videos, but I'm way more concerned starting to like this last section that you know how to set up the integrals. Like here, you're just making sure you do top minus bottom. So it's not that big of a deal, but you're about to do volumes instead of area. So I'm way more concerned that you can set up the integral than doing all the work out excess, because some of them, again, like with trig, won't be able to be solved. So then I would say just make sure that you can use NINT as much as you want on this coming assignment. Coming back to Zoom.
This is our, so we have one more assignment than the quiz.